Good morning, everybody. I am Dr.Dhondiba, Assistant Professor of Chemistry, Government First Grade College, Kerala, Bangalore. Today, I am going to discuss about second session of Chemical Kinetics, which belongs to third semester BSc, affiliated to Bangalore North University. In this session, I have to discuss about second order reaction. Now, objectives of this session. First objective goes to derivation of velocity constant of a second order reaction when both concentration of the reactants are not same. That is, A is not equal to B. Second objective of this session is expression for half-life period of a second order reaction with A is equal to B. Now, after completion of this session, you will gain the knowledge to derive the velocity constant of a second order reaction when the both concentration of the reactants are not same. And you have also easy to write the expression for half-life period of a second order reaction with A is equal to B. Now, before going to this session, you already know about the second order reaction and derivation of the velocity constant of a second order reaction when both concentration of the reactants are same, when A is equal to B. SI unit of second velocity constant of second order reaction when both concentration of the reactants are same, and mathematical operations like integration, partial fractions you have already learnt in previous session, that is the first session of chemical kinetics. Now, derivation of expression of velocity constant of a second order reaction with the concentration of the both reactants are not same, that is not A is not equal to B. For that, consider a second order reaction A plus B formation of products. The rate of the above reaction is determined by change in concentration of reactants A and B. Therefore, that is dx by dt is equal to K into molar concentration of the reactant A into molar concentration of the reactant B. Call equation number 1. For that, we can write that is A, consider A plus B is equal to product at initial time before reaction to takes place, that is at time t is equal to 0, let A mole per dm cube be the initial concentration of the reactant A and B mole per dm cube be the initial concentration of the reactant B. And the product, there is no product because at time is 0. Let X be the degree of dissociation of a reactant into product. Then after time t, the remaining concentration of the reactant A is equal to A minus X, and remaining concentration of the B is equal to B minus X, and product will be a X. This can be same, we can write in words. Let same we can write like that. Let A mole per dm cube be the initial concentration of the reactant A, and let B mole per dm cube be the initial concentration of the reactant B. After interval of time t, let X mole per dm cube of each reactant A and B be the consumed to form the products. That is the molar concentration of the reactant A is equal to A minus X, and molar concentration of the reactant B is equal to B minus X. Then the rate of formation of the product is given by the concentration of the reactant at instant is dx by dt is equal to K into A minus X into B minus X, because here we are putting value of molar concentration of the reactant A is equal to A minus X, and molar concentration of the reactant B is equal to B minus X in equation that is 1. We'll get this equation number 2. Then you have to make cross multiplication, that is just you make the variable separations. Dx by A minus X into B minus X equal to K into dt, and this can be solved. We require that is making the integration. For that, you have to make simplify by using a mole fractions. Let 1 divided by A minus X into B minus X equal to P divided by first fraction a minus x plus q into b minus x fraction. Take LCM a minus x and b minus x on both sides. We will get that is a 1 divided by a minus x into b minus x equal to p into b minus x uh, plus q into a minus x divided by a minus x into b minus x. Then you have to cancel these both, that is a minus x and b minus x on both sides. You will get that is a, therefore we will get that is a p into b minus x plus q into a minus x equal to 1. Now you have to apply the condition. First you have to take b minus x is equal to 0. Then this implies that is a b is equal to x. Substitute this b is equal to x and x is equal to b in this equation. What you get? Therefore, suppose putting that is x is equal to b means b. Therefore, here x minus x became 0. Therefore, whole term, that is p term, will be a vanished. And here a is equal to, you are putting that is a x is equal to, no, x is equal to, we are putting b. Therefore, q into a minus b equal to 1. Therefore, after transferring, q is equal to 1 divided by a minus b we will get. Again you have to put a minus x equal to 0. Then this implies a is equal to x. Substitute a is equal to x and x is equal to a in this equation. Therefore, we will get that is a, after putting a is equal to x means this term, that is q term, will be a vanished. And here we are putting that is the x is equal to a here. Therefore, we will get that is p into b minus a is equal to 1. But I require that is a minus b. Therefore, I take that is a minus is the common factor. Therefore, common minus will be comes outside. Then we will get that is a minus b equal to 1. Therefore, transfer this value in right side. Therefore, we will get that is p is equal to 1 divided by, that is p is equal to minus 1 divided by a minus b. Substitute the value of p and q in equation this. Here that is a letting know, in this equation you have to substitute and simplify. You, therefore we will get that is 1 divided by a minus x into b minus x is equal to, the p value you have to substitute, minus 1 divided by a minus b, this much, into b minus x remains as it is, plus q value is nothing but 1 divided by a minus b into a minus x. Then this is the remains as it is, and for that you have to take 1 divided by a minus x is the common factor. Therefore, 1 divided by a minus common factor, remaining will be a, will get that is a, first I have to write this is the a minus x here, then this will be a minus into b minus x. Then make it is a separation, variable separation. I can write that is a 1 divided by a minus b into a minus x divided by a minus x into b minus x, minus of b minus x divided by a minus x into b minus x. Then we will get that is a minus x and a minus x get cancelled. It will be remains 1, and b minus x and b minus x, that will be remains a minus x. Therefore, we will get that is this like product will be formed. Therefore, 1 divided by a minus x. Therefore, 1 divided by b minus x minus of 1 divided by a minus x. Now substitute this value in equation number 2. Therefore, we will get that is a 1 divided by a minus b into 1 divided by b minus x minus of 1 divided by a minus x into dx is equal to kt. Now taking integration sign on both sides. Now here integrating on both sides, you will get that is the integration of 1 divided by a minus b into 1 divided by b minus x minus of 1 divided by a minus x, the bracket closed, into dx is equal to k into integration of dt. Here again you have to take that is a 1 divided by a minus b as a common factor, you have to take outside. here, that is outside the integration constant. Therefore 1 divided by a minus b into integration of this should be a actually here one bracket, big bracket will be there, integration of 1 divided by b minus x dx minus of here integration of 1 divided by a minus x dx is equal to k is constant, k is comes outside, k into integration of dt. Now here this actually this here bracket should be there here. Now 1 divided by a minus b into take the, that is 1 divided by x, like no, therefore it is the integration is taking, that is a ln of x. Ln of x means ln of b minus x, and again we know that here minus will be there, no, this is actually no how it is takes place. Integration of 1 by x means that is a log x, no, therefore log x instead of log x we can write that is the ln x. Ln x means ln b minus x into this is the minus value, minus sign of the x, no, that should be a multiply here, therefore it will become a minus ln of b minus x, again minus is remains as it is, into here again 1 by a minus x will be there, therefore it is the ln of a minus x, due to having a minus sign of x will be there, that will be a into x, therefore here multiply, and this is the whole bracket close, this is equal to k into the integration of dt is nothing but t, and plus c is the integrating constant. Now you have to simplify further, we will get that is a 1 divided by a minus b into 1 minus ln of b minus x plus minus minus plus, it is a plus ln of a minus x, close the bracket, and equal to kt plus c. Then you have to apply that is the logarithmic property, 1 divided by a minus b ln of, this is the I take this is the first, that is log of m minus n, no, this is the m, this is the n, no, therefore I can write that is a ln of a minus x divided by b minus x equal to kt plus c, that is called equation number 3. Taking by this is the logarithmic property, that is called equation number 3. At initial of a reaction, when time t is equal to 0, x is equal to 0, you have to put these values for getting the value of c. This value, substitute the time t is equal to 0 and x is equal to 0 in equation number 3. You have to calculate the value of c here. Then after putting 1 divided by a minus b into ln of a is a minus, this is the 0, and b minus 0, therefore ln of a by b, therefore equal to, it is a t is nothing but 0 means this term became a 0, therefore equal to c. And substitute this value equation number 3, substitute this value in equation number 3, we will get that is what is that, here 1 divided by a minus b ln of a minus x b minus x as it is equal to kt plus c is nothing but 1 divided by a minus b into ln of a by b. Again you have to transfer, that is kt, we require that is a rate constant, that is a k value, no, therefore kt is equal to, just transfer, therefore 1 divided by a minus b ln of a minus x divided by b minus x minus of, that is a 1 divided by a minus b ln of a by b. Again you have to take, that is a common factor is nothing but 1 divided by a minus b. Therefore kt is equal to 1 divided by a minus b into ln of, by logarithmic property we will get that is a a minus x divided by b minus x minus of ln of a by b. By logarithmic property what you write, that is log m minus log n, no, that like, therefore 1 divided by a minus b into ln of b, therefore b into a minus x divided by a into b minus x, and transfer this t to that side. Therefore we will get that is a k is equal to 1 divided by a minus b t ln of b into a minus x divided by a into b minus x, bracket close. Therefore k is equal to 2.303, because we are convert that is a natural logarithm into common logarithm for calculation purpose. Therefore that should be a converting by multiplying 2.303. Okay. Therefore multiplying we will get that is a 2.303 divided by a minus b into t log of b into a minus x divided by a into b minus x, and this equation is called the expression of velocity constant or rate constant of a second order reaction when a is not equal to b. Then coming to that is the unit of second order rate constant. The rate constant of a second order reaction is measured in per mole dm³ per second, or per concentration per time is the unit of this velocity constant. Then again we have to calculate now, that is now coming to that is a half life period of a second order reaction. Now half life period, now the time, how do you define that is half life period of a second order reaction? The time required for the concentration of the reactant to decrease to one half of its initial value of a second order reaction is called half life period of a second order reaction. It is time required for the concentration of the reactant to decrease or to reduce, to come down half of its initial value of a second order reaction is called half life period of a second order reaction. It is represented as T half, or that is a T 0.5. Now coming to that is a derivation of an expression for half life period of a second order reaction with A is equal to B. When we know that rate constant of a second order reaction when A is equal to B is nothing but K into 1 divided by T into X divided by A into A minus X. This expression derived in session 1. Okay. From that equation, for half life period T is equal to T of, or we can write T 0.5, or it is also called 1 divided by, this is the half of its initial value, means A divided by half, that is 1 divided by 2 into A. This can be written as 0.5 A. Therefore substitute A minus X, we require A minus X value. A minus X value means A remains as it is, and X is nothing but just say that is a 0.5 A. Therefore we will get that is a, what is that, X is equal to 0.5. After that is getting, we are calculating X is equal to 0.5 A. Then substitute these values, we will get what is that in this equation. What you get here, the K is equal to 1 divided by T half 0.5 A divided by A into 0.5 A. This 0.5 A, this 0.5 A get cancelled, therefore it remains A. Therefore K is equal to 1 divided by T half into 1 divided by A, or this can be also can be written as T half is equal to 1 divided by K into A. And this is, suppose you are meaning that is the T half is directly proportional to, that is inversely proportional to its initial concentration. Therefore here K is a proportionality constant, it is also called as a velocity constant. Thus the time required for the completion of half of the reaction of a second order reaction is inversely proportional to its initial concentration of the reactant. Now coming to the unit of SI unit of the second order half life period of a second order reaction. The half life period of a second order reaction is measured in terms of seconds. So far we have studied in this session derivation and expression of velocity constant of a second order reaction with when the concentration of the reactants are different or not same. Second, we know also studied that is SI unit of velocity constant of a second order reaction. And third one is half-life period of a second order reaction. The definition we know. Okay, we have already discussed. Then derivation of expression of half-life period of a second order reaction with A is equal to B also you have to study. And last, SI unit of half-life period we have also studied in this session. So far, therefore, I will ask some questions. You have to answer the questions. First question goes to, if A be the initial concentration and X be the consumed in time t, then after time t, the remaining concentration of the reactant is, the option will be A by X, A minus, B option is A minus X, C option is X minus A, and D option is A into X. I will give just 10 seconds for you people. You have to think and you have to choose the correct answer for this question. Now answer for this question is B option, that is A minus X be the correct option, because A is the initial concentration, X will be a consumed. After time t, the A minus X be the remaining concentration. Therefore, A minus X be the correct answer for this question. Second one, SI unit of half-life period of a second order reaction is, we know that SI unit of half-life period of a second order reaction is, the option is given A, that is a S, that is second, B per second, C is mole dm cube per dm cube second, and D is none of these. These options are there. Again, I will give 10 seconds for you people. You have to choose the correct answer. Answer for this question is A option, that is a second. The half-life period is measured in terms of second or time. Okay, always that is time is measured in seconds or time, no. Therefore, the SI unit of half-life period is, that is second. That is A option is the correct option for this question. Third question, which one is true of the following? First one is goes to, half-life period of a second order reaction directly proportional to the initial concentration of the reactant. B option, half-life period of a second order reaction directly proportional to square of the initial concentration of reactant. C option, half-life period of a second order reaction inversely proportional to the concentration of the reactant. And D is the none of these. Now you have to think which one is the correct. Now out of that is the 4, one will be correct and others are wrong. I will give 10 seconds for you people. You have to choose correct option. Answer for this question is C option. Half-life period of a second order reaction is inversely proportional to the initial concentration of the reactant. This is the after deriving, no, we will get that is a T half is equal to, that is a directly proportional to 1 divided by A, no. Therefore, this C option will be the true, and these are the directly proportional, it is not true, and square of the initial concentration, that is not true. Only C option will be a correct one. Therefore, answer for this question is C option. Half-life period of a second order reaction is inversely proportional to the initial concentration of reactant. Fourth question is expression of a relationship between half-life period and second order reaction is first option T half is equal to K divided by A. B option is T half is equal to A divided by K, and C option T half is equal to K into A, and D option is T half is equal to 1 divided by K into A. Choose the correct answer. I will give 10 seconds for you people. Now option for this question is D option, that is T half is equal to 1 divided by K into A. Therefore, after that is a T half life period, that is deriving no half life period of a second order reaction is equal to, we will get 1 divided by K into A. This is the correct answer. Therefore, D option is the right answer for right option for that is the fourth question, that is expression of relationship between half life period and second order reaction. And this completes that is session number 2. For preparation of this session, I have used or referred these books for preparation. Thank you.